Welcome to the enclosure. Tomorrow is pour day, so I thought I'd give you a quick run through on the prep that I've done for the basement floor slab. So the first item that you'll see is a green membrane. This is called Perminator, and I'll scan over here. It is a 15 mil thick membrane. It's quite durable. It's nice to work with because it is rigid, so it makes it easier to lay out. My only issues with it are that if you try to just pull the folded seam tight, you won't get there. You actually have to go through, which is what I did on later sheets, and flatten out the membrane. The other issue that I found, and that because there is creases that develop as it's being rolled up, so at the factory, so for instance like that, it makes sealing those details a little bit more difficult, but not insurmountable. The other annoyance is that, as you can see, you're generally wanting to install this labels up, and as you can see by, let's see if we can get that focused, as you can see by the crease, it's actually folded so that you actually have to how do I just describe this? This side's folded underneath, so it has to fold up this way instead of it just going like that, which is a bit of a pain in the butt. But it is an extremely durable membrane, and the red tape that's sold with it is very high adhesive. It's probably the highest adhesive tape that I've worked with to date. It's a lot more adhesive, for instance, than the zip tape that you can buy, and it's also very durable. You can see little places like this, because it is so high adhesive, it does tend to trap some air bubbles. You have to be very careful in how you're applying the material, so that basically you're pushing it down as you unroll it, but because it's so difficult to unroll, it's almost a two-man job. In places where there was a location where there was a continuous airstream, I just patched those up with another piece of tape. So at the borders, the exterior borders, I have sealed it to some membrane, and I'll mention this a little bit more on my blog entry where I show you how the membrane was sealed to the footing. Because this is a ROXUL ICF, it's permeable, air permeable, so you can't seal anything to it directly because it'll just bypass that. So this membrane actually goes down and seals to the concrete footing, which I know is non-permeable. You also see in this photo XPS. So I'm down 12 feet. The contribution to slab edge losses isn't huge. There is perimeter drainage in behind that, because it's drawing water away, will become a thermal bridge. So you do want some slab edge insulation, but more importantly, you want a bond break between the foundation wall and the slab. And by using this, I've also set the elevation of the slab, making it really easy for the pour crew. The inside edges I have sealed to just standard vapor barrier poly that I had previously stripped in underneath my interior footings. And if you go way back in my blog, you'll see that and you can't see it here, but the interior footings were stripped in using a high density XPS foam. And I don't think there's any place where that's still exposed, but basically I had XPS foam that I put all the way around this footing so that there would be a continuous thermal break, and then I line that with poly. If I was doing this again, I would have bought the Perminator much earlier in the process and used it for aligning the footings. I had to take a lot of care to ensure that the poly wasn't damaged up until this point in construction. And this particular wall doesn't have anything, or footing doesn't have a wall built on it yet. It's a seismic wall. It's a braced wall panel, and it's an offset because the upper floor was set back from the lower floor, so it required a plywood clad braced wall panel down in the basement here. It's not needed because of the width of the basement. I'm within my allowable tolerance. So that's basically the vapor barrier, the gas barrier, water barrier that I've installed. Below the Perminator, I've got 4 inches of dense mineral wool. It's called Comfort Board 110, and we'll just go take a look at that product. It's a lot denser than the Comfort Board 80 that I'm putting on the outside of the building, but it is approved by, and they're actually called ROXUL now. They've rebranded, but it's approved for below grade, below floor slab installation. And it is softer. You have to be a little bit more careful on your construction, ensuring, like, for instance, you're not rolling wheelbarrows across it continuously, or repeatedly walking in the same area. Where I was walking continuously, I would put down running boards that I would walk on to prevent overcompression of the mineral wool. For plumbing penetrations, because the insulation is somewhat compressive, I was worried that if these were taped, that as the concrete was poured and pulling down, it would just rip the tape off the plumbing stacks. So let's just get this focused again. I have put down a foil-faced peel stick that I used an adhesive to ensure that it bonded to the Perminator, and then I used my favorite liquid flashing material, R-Guard, and in this particular case it's joint and seam, and it has the embedded fibers. And let's see if I can get in without losing focus, and you can see there's a lot of flexibility. I can't remember what the modulus of elasticity is, but it was very high. So now I don't have to worry about that opening up and losing my continuity as the slab is poured. I've got a little bit of a buck out for a shower basin that's going to go into that location. You'll also notice that on the floor drains, I've got masking tape that's identifying the top of the slab, and that will be because this little area that you can sort of see outlined by the tape, that, for instance, is my sauna, and it will all be sloped down to a floor drain. Okay, what else do we got here? Pretty straightforward installation. It took probably, I'm guessing for me, 2 weeks to install the insulation and membrane, and then a little bit longer to do all the fiddly detail work. For my floor drains, they all have trap primers, which means that a little bit of water will drip into them as a specific tap in the house is used. It's going to be the shower riser in the master bathroom, and that will come down to a distribution unit that will divide it into the 4 traps that I have down here. And where the PEX pipe was routed through gravel, I've just routed it through a PVC liner sleeve that instead of using fittings, I just took the torch to heat it up a bit and bend it into the shape that I wanted it to be. Obviously I wouldn't do that with anything that saw live pressure, but for a sleeve it worked just fine. Okay, now the exciting bit in the basement is that it contains a full-scale mock sub-slab insulation lab where I'm going to be testing 4 different installations of insulation. Over on our left-hand side, we've got 10 inches of the Comfort Board 110. That will be to emulate, for instance, what sometimes is done on Passive House community. Then the next one over is 4 inches again, just 4 inches instead of 10 of the Comfort Board. That is what I have in the rest of the house. And then we've got the Foamular 20 XPS from Owens Corning. And then on the next one, we have a similar compressive. I can't remember. I'll post it on my blog, but it's about a 20 psi EPS, which is pretty much the industry standard for sub-slab insulation. Below that, I've got a drained granular layer. Now, there's been a lot of debate in the building science and building construction community about what insulation is the most appropriate for below slab. The industry standard is EPS because it's cheap. The people that are building more environmentally friendly buildings like EPS because it has no global warming potential compared to the XPS. The XPS doesn't have ozone depleting properties to it, but it still has a very high global warming potential. The issue, however, is, and there's a debate of which one wets up more, and I'm going to try to get this, while I talk, I'm going to try to get this a little bit more stable for you. Let's see what we can do here. So there's a lot of debate within the industry of which one wets up more. XPS, based on its specifications and based on a lot of tests that have been done by different firms, building science firms, wets up much, much slower than EPS. EPS wets up quite quickly. However, XPS dries out slower than EPS, which dries out more quickly. But it really depends on the wetting and drying cycles to determine which one will wet up faster and stay wet the longest. In a wet environment, say like a podium, where you've got a cement slab and then you've got some insulation and then you've got a walking surface on top, that material is basically going to stay wet for the majority of its lifespan. And both products are going to wet up tremendously and start to lose their thermal characteristics. So the purpose of this test is to identify which ones will wet up the fastest and stay wet the longest. And you can see in the background, I've got little conduits. Each panel has a set of instruments that's going to be measuring the temperature and the water content of the material. And then at the end of a test period, we will take out a series of samples that are in the middle of these buckouts. So these buckouts are going to be concrete lids that go over top of the lab area. The lids will be lifted off with a jig. They will allow to measure the compressibility of the 4x6 concrete pad. so the compressibility of the insulation. But most importantly, they'll allow it to be removed and to access samples that are going to be down the middle. And there's going to be 3 sets of 16 by 16 inch samples on each of the labs. They will then go to the local technical college, BCIT, where we will do hot box testing to determine what the thermal degradation is of the insulation over time as it's wetted up. And I've included the ROXUL because I now see that as being a very suitable alternative that is should be free draining and not have the wet up issues that the rigid foams have, and it also has a much lower embodied energy, a much lower global warming issue, and no ozone. Okay, so that is about it. We're going to pour tomorrow morning, and hopefully all will go well. Off in the background there, last 2 things I'll mention is my water level sensors. I've got a dip tape, so it's just a tape measure on a float that'll tell me the level of the water table below the gravel, and then on the left side is an electronic one which will measure. Again, it's got a float and resistors inside the stem that measure the height. Over here, we've just got the sanitation sump. All of the basement sanitation runs to the sump and then gets pumped up to the gravity feed to the district. Okay, so hopefully everything will go well, and we'll talk to you again in the near future. Thanks for visiting.